Hi, my name is Annalisa Maui, and I was a project manager for our senior design group. Our group of 5 San Diego State students, all majoring in mechanical engineering, worked with NIWC PAC to create a multi-AUV deployment system. NIWC's Unmanned Maritime Vehicle Lab is currently using remotely operated vehicles known as Blue ROVs to serve as low-cost autonomous underwater vehicles. Currently, the Blue ROVs are deployed by hand by a person on a kayak or a small boat alongside an unmanned surface vehicle that they use to remotely communicate with the Blue ROVs. Our goal was to design a system that attaches to the USB in order to remove direct human involvement and simplify this process.
Hi, my name is Gabriela Garcia, and I was a design lead during this project.
Our design stemmed from the idea of a drawbridge mechanism with a lowering ramp capability. With this in mind, we designed a device consisting of 3 sub-assemblies. The first sub-assembly is the mounting plate, which is the attachment unit of our device onto the pontoons of the USV. The second sub-assembly is the ROV housing that was designed to perfectly hold a Blue ROV at an incline that creates a ramp when the door is fully opened. The last sub-assembly is the electronics housing, which drives the deployment sequence. We built 2 identical devices that sit on opposite sides of the USV and are both controlled by a single remote. This allows us to meet our first goal of deploying 2 Blue ROVs from the USV.
Hi, my name is Remy Wilkinson, and I was the manufacturing lead for this project. In order to successfully accomplish our design, we chose to water jet the parts that make up our mounting plate and ROV housing subassemblies out of starboard material. We then used a hand drill to precisely place all holes for each connection point. We altered a water-resistant box that we used to house our electronics by dremeling excess material and drilling 3 attachment holes. We also used a 3D printer for small parts using PLA. The materials were chosen due to their lightweight, durable, and water-resistant properties to satisfy our second goal of our device being water-resistant and functioning well in its intended environment. We also met our third goal of staying under the 51-pound weight requirement, with each device weighing 47.3 pounds.
Hello, my name is Gary Valdez, and I was the electronics lead for this project. In order for our device to successfully actuate, the use of electronics was required. Now, there was 2 primary electronic systems that I designed: a radio frequency remote communication system, as well as a system that unspools the cable, lowers the door, and begins the launching sequence. The latter subsystem, called the electronics housing, is highlighted by the 30-to-1 worm drive gearbox that is paired with a stepper motor. Because of this specific gear ratio, the gearbox is considered self-locking. This will safely and effectively keep the door closed when the system is not in use, securing the ROVs on the USV pontoon until the moment of launch.
Hello, my name is Maxwell Yant, and I was the quality and testing lead for this project.
The second primary electrical system in our design is the remote. The remote functions by serial communication with the electronics housing to initiate the launching sequence. We've incorporated the usage of RF antennas to achieve a greater distance of communication between the HC-12 modules. These antennas help to accomplish the remote deployment goal of at least 20 meters. For the physical design of the remote, we tried to make an ergonomic handheld device with 2 toggle switches at the bottom, one for each deployment system.